Good morning all. So here we will again trace the code that we have discussed already, which is binary tree construction. Fine. So in the last class I have taken the same example. Now let us consider a binary tree that I want to create, whose root value is I think it was 4, and then left child of that 4 is 5, and then left child of 5 is 7, and there is no left child of this, and this is null, and this is also null, and it has one right child, this is null. Okay, these are null, which indicates there is no right child for this, there is no left and right child for this, there is no left and right child for this. So let us quickly understand how this whole process binary tree get implemented is that. Let us consider the very first node, which is the root node. When we enter the root node whose value is 4, it asks to enter the left child of node 4. Now let me give the value 5, then again it will ask to enter the left child of 7. If I want to further insert the left child of 7, then it will keep on ask until the left child become null. Okay. So once there is no more insertion required, then it will ask the last node to enter the right child of that. If there is a right child for that last node, if we enter, then that node will be created and then the link get established. Once it is completed, then it backtrack to the previous node, and then it will ask to enter the right child of the node, which is 5 over here. If I want to insert one new node, I can insert. Now in this case there is no right child, so I'll give -1 so that it will stop return condition over here. Then it will backtrack to the node which is 4 over here. Then it will ask enter the right child of 4, which is 6. Then again it asks enter the left child for 6 and then right child for 6. If I am inserting more node, it will keep on inserting. Whenever I do not want to insert any node, I have to enter -1. So -1 is the stopping condition. Okay, this is the overall flow of this binary tree recursive algorithm. Now let me trace this function with the help of an example. Note down any function or this is the function called create. It gets called from the main method. Okay, I am assigning root equal to create. Okay, so create is the method. I call this method and I am going to assign the address returned by the create method to the root. So in that case, root is a pointer variable. Now you note down create. Create is the method whose return type is struct node star. That means it is going to return the address. Fine. So with this, let me initialize the stack and how it gets called. So for the very first time, main gets automatically. So in the stack, main method gets initialized, and then all the local variable of the main method gets initialized, and then it calls the function create. Okay, so this gets called create method. In this create method, actually this is considered as a stack frame. This stack frame I have expanded over here. Whenever the method gets called, a stack frame is created whose with the same function name create, and all the statement which is written in the create method gets executed one by one. Okay, now let us consider the first stack frame. In the first stack frame, the first line is line number 1 gets executed. It will declare the variable integer x. The line number 2, it will declare the pointer variable, which is new node. Then 3, enter data, -1 for no data, so it just print. Then it's in the line number 4, x gets suppose if I am giving the x value is 4. Okay, I am giving the 4 value here. In line number 6, x equal to -1, no, because I have given the x value is 4 now. And then it will not execute line number 6. It comes to line number 7. In line number 7, it will try to allocate the memory using malloc function size of struct node. Note down the structure is already declared inside the program, which consisting of pointer to the left node, pointer to the right node, and then a node itself whose value is stored, actually integer value, which is nothing but x over here. Then when we call malloc function, it will return some address. That address is stored in the new node. Fine. So now when it creates using malloc function, so let me write it in the corner. So this will create a new node, okay, new node whose address is, let's say, 100. Fine. So that has been allocated using malloc function, and it returns the address, which is nothing but the 100 pointed by the new node. Okay. Then it comes to the line number 8. Line number 8, new node of data equal to x. Now new node of data, this part, x get assigned, x value is 4, that gets assigned over here. Then line number 9, printf enter left child of %dx. What is the value of x? Which is 4. Printf or print enter the left child of 4. Okay. So it just asks enter the left child of 4. If I am interested to create the left child of 4, then I have to call the create method again recursively. So note down, it will call again create function. Now another, when I am calling the create method again, another at the line number 10, it gets called, it will create the another stack frame. Okay, another stack frame. Now note down, the new node address is here 100. It is called another stack, it is called again, so it creates another stack frame. Now it is going to execute this line one by one. Line number 1 gets initialized, line number 2 gets initialized. It will ask enter data. Now I am going to give the data, which is 5. So I want to create the node 5, and I want to make this 5 as the left child of 4. Okay. So now x is equal to minus 1? No. So it will not execute line number 6. It comes here, line number 7. Line number says that malloc size of struct node. So now, okay, this time only, line number 7 only, it will create this malloc function, and it will return the address, let's say 200. Okay, now new node is pointing to the 200. So now let me have the 200 value over here, and then line number 8, new node of data equal to x. What is the value of x? I have given the x value that I have given is 5, right? So that 5 get assigned over here. I have already assigned. And then line number 9, enter the left child of x. What is the value of x? Which is 5. Okay, so it again asks enter the left child of 5. Okay, if we are interested, it will call create. Okay, create, and then it will again create a stack frame. Okay, upon executing line number 10, okay, it will create another stack frame, okay, whose method is create. Then here line number 1 gets executed, line number 2 gets executed, line number 3 gets executed, and 4 it is asking to print any left child of 5. And then let's say I am giving the value 7. Okay, x value is 7 because I want to insert 7 as the left child of 5, and then it will check x equal to minus 1. No. Okay, so it will not execute this. It comes here new node equal to malloc size of struct node. So this time it will create another node, okay, of the type pointer variable. Let's say it creates 300. New node is 300, which is 300 is nothing but the pointer variable. And then new node of data equal to x. What is x? 7. So that gets assigned over here. Then it again asks enter the left child of, what is x value? 7. Enter the left child of 7. Okay, it prints, then again it call new node of left equal to create. So it again call create function. Upon executing line number 10, it again gets called another, okay, once again it gets called. So now what is the address written over here? Let's say 300, it's get copied. So this is for our understanding, I am writing here. Actually here new node is pointing to 300, here the new node is pointing to 200. In this stack frame the new node is pointing to 100. If we keep track this new node address, then it becomes easy to understand the tracing. Then upon executing line number 10, it gets called, again it will execute line number 1, 2, 3. Now let's say I do not want to insert any left child of 7, that means null. Okay, I have to give -1 for no data. Suppose let's say I'll give the x value is -1. Now this condition become true, x equal to -1, yes, so it returns 0. Okay, so where it returns? It will return 0 from where it has been called. Okay, so whenever it returns okay, to the previous call function, this stack frame gets popped off automatically from the stack. So this stack frame gets popped automatically, so it has been deleted. Now since the last call was happened at the line number 10, it returns to the line number 10. Now note down line number 11, 12, 13, 14 or the left portion has to be executed. Okay, now it comes to this stack frame. In this stack frame, it starts executing from the line number 10. Now what it returns? It returns 0. Okay, so it returns 0 so that it's returned to this line number. So line number 10 is new node of left equal to 0. That means null. Okay, you can write null also. New node of left. What is the new node here? This stack frame new node is nothing but 300. The new node is pointing to 300. New node of left means this one. New node of left. Okay, so this is 0. That means null. Fine. Now after completing this, line number 11 gets executed. Note down line number 11, printf enter the right child of x. So what is x here? X is pointing to this stack frame, so 7. It will ask enter the right child of 7. So if you want to insert any right child of 7, if so you can insert. So now it asks, it just print this, then line number 12 get executed. So new node of right equal to create. So it again called create function at the line number 12. So now note down another stack frame gets executed. Now once again all statements gets executed. Now I don't want to insert any right child for the node 7. Okay, so now at the line number 4, suppose if I'll give x equal to -1, this condition becomes true, then it will return 0. Okay, it will return 0. Where it will return? From where it has been called. So this stack frame gets called at the line number 12. So while it returns, this stack frame gets popped automatically. Then it gets resumed from the line number 12. Now we have to execute from line number 12. Now line number 12 says that new node of right equal to create. The create is already written 0. Okay, but where we have to assign new node of right. What is new node? New node still point to 300. 300 right, we have to assign the value 0. Okay, I think the first trace is going to complete. After executing this, return new node. Line number 13, return new node. What is new node? New node is having some address. That address is written from where it has been called. So 13, it returns new node. What is new node? New node is nothing but 300. So this stack frame new node address is 300. That gets returned from where it has been called. Okay, from where it has been called? It has been called from the previous stack frame at the line number 10. Okay, so this will get executed from this statement to the previous. So it has returned to this line number. From this line number, let us start executing one by one. So what the line number 10 says, new node of left equal to create. Now what is the value that has been written? The new node value whose address is 300. 300 gets assigned to new node of left. What is new node now in this stack frame? New node is nothing but 200. Okay, so go to the 200 which is nothing but new node of left equal to 300. Okay, so I'll copy here new node of left equal to 300. So logically it has been established the link from here to here. Okay, now the 7 has become the left child of 5. Okay, so line number 10 completed. Now let us come to line number 11. Okay, line number 11, printf enter the right child of x. What is the value of x now? X is 5. Now it is asking printf the value right child of 5. Okay, and then line number 12, new node of right equal to create. Now create, it gets printed. Okay, nothing has to be executed. Then it calls create function. So line number 12 gets called the create. So another stack frame gets created. Here line number 1, 2, 3 gets executed. Upon executing 4, let's say I don't want to insert a right child for 5. Okay, at that time I will give -1. So x equal to -1. Now in this condition, x equal to -1 will become true. It will return 0. Okay, so where it will return? From where it has been called. So it returns 0 to the line number back to the 12. Fine. So it returns to the line number 12. From line number 12 we can say new node of right equal to 0, because create has written the value 0. So what is new node? New node is 200. 200 of right is having 0 now. Logically it is having the null pointer. Fine, it points to the null. So that means it does not have any right shell. Then line number 12 completed. Line number 13, return new node. Now what it returns? Okay, new node address. New node address is 200. Upon executing 13, it returns new node. New node is nothing but 200. 200 gets written where it has written, from the line number from where it has been called. So from line number 10 it has been called. So we are returning the value 200 back to the this stack frame. Okay, here 200 gets written. Now what we are going to do? We are going to execute this statement, new node of left equal to 200, because 200 gets written. Now new node is nothing but 100. Okay, 100 left. New node of left is nothing but I am assigning this node address, which is 200. Fine. So line number 10 completed. Line number 11 has to be executed. So upon executing line number 11, enter right child of x. It will ask enter the right child of x. What is x value? 4. Right child of while copying it has been established the link. Okay, now it is asking enter the right child of 4 if any. Okay, then line number line number 11, line number 12, new node of right equal to create. Again creates get called from the line number 12. So now line number 12 gets called. It will create a new stack frame. Okay, now line number 1 gets executed, 2 gets executed, 3 and then 4. Now if I want to insert a right child for the node 4, I'll give the value, let's say x equal to 6. Fine. Now x is not equal to -1. It will not execute. It comes to the line number 7. Okay, a new node has been created using malloc function. Okay, and then let's say its address is 400. Fine, 400 will be created with the new node value. So let us copy the value for our understanding 400 here. Then line number 8 get executed. Line number 8 is you are copying x to the new node of data. Now the new node is pointing to 400. Here I am copying the value of 6, which is 6. Fine. Now line number 9, enter the left child of x. What is x here? 6. It asks enter the left child of 6, and then it will it just print and then goes to the next line. What is the next line? Line number 10. Okay, and then line number 10 gets executed. It calls create. So create gets called. Okay, another stack frame gets created. Now line number 1 gets executed, 2, 3, and then 4. Now I don't want to insert any left child for the node 6, let's say. Okay, but it asks. Okay, upon executing, so line number 10, okay, it gets called create. Now it scanf. So suppose I'll give x equal to -1 now. Now this will become true, it will return 0. Okay, where it will return? Return 0 back to the line number 10. Okay, so it will return 0. So new node of left equal to 0. So what is new node? 400. 400 left now is pointing to 0. Okay, so this is 0. Now line number 11 gets executed. Enter right child of x. What is x value? 6. It is asking enter the right child of 6. Okay, that gets called line number 12. New node of right equal to create. Now 12 will again called a create function. Okay, again line number 1 gets executed, 2, 3, and so on. At the line number 4, suppose let's say I'm giving once again -1. Okay, stopping condition. It will return 0. Where it will return 0? To the line number 12 now. Okay, so it will return 0. Now it will assign new node of right equal to 0. What is new node? New node is 400. 400 right equal to 0. Fine. Now this statement 12 executed, and then 13 return new node. The last statement, the new node is nothing but 400. 400 gets written and then curly braces. So 400 gets written where? To the line number 14. Okay, so line number 14, this stack frame become active now. Line number 12. So what it says? New node of right equal to 400. What is new node? 100. Okay, 100 right child should be 400. So I have to copy the 400 address here. Okay, logically 400, physically the link has been established. Okay, upon executing line number 14, now 13 gets executed. Now return new node. So what is new node value? Now 100. Okay, this is the last step. So 100 is going to return from where it has been called. From it gets called to the main function. Note down, in the main function we have assigned, in the main function I have called like this. Okay, root equal to create. Okay, now create is a function. Now it is written 100, which is the root node address. That 100 gets copied to the root. So now this 100 is pointing by the pointer root node. Okay, in case of linked list, we maintain the starting address in case of linked list with the help of the pointer called head node or the start node. In case of a tree, we have to maintain a pointer which is necessary, which is pointing to the root node. Okay, upon executing the whole program, after finishing the main program, main also gets deleted after completing the program. Finally the stack becomes empty. So this is the overall trace how the whole recursive method gets executed. I think this lecture video will be helpful for you to understand. Thank you.